Compare relationships with equations. These notes are in your book. The learning targets for this lesson are: I can decide if a relationship represented by an equation is proportional or not. For this first example, we are going to use the equation F equals 9/5 times C plus 32, where F is the degrees in Fahrenheit and C is the degrees in Celsius, and we're going to complete the table. So the first one, we want Celsius, so the C value is 20, and we're going to take that times 9/5, and then we're going to add 32, and then see what that equals. If you type that into the calculator, you would get 68 degrees Fahrenheit. And the next one, we're going to put in 4 for the C. So 9/5 times 4 plus 32 equals 32.2 degrees Fahrenheit. And the last one, we have 175. So we're putting that in for the C value. 9/5 plus 32 equals 347 degrees Fahrenheit. Is this a proportional relationship? Explain why or why not. So what we would have to do to figure out the proportional relationship is take our F values and divide by the C values. So you would take 68 divided by 20 and see what you get, which would be 3.4. And then you would take 32.2 and divide that by 4. And you get 8.05. And finally, you could take, if you wanted to do all of them, 347 and divide that by 175. And you get 1.98. So since these are all different, this is not proportional. And your reasoning could be your constant of proportionality is different for each of the rows of your table. For this next one, we have the equation C equals 2.54n, and this is the conversion from length in inches to length in centimeters. So we're going to just multiply everything times 2.54, and that's going to give me 25.4 for the first one. For the second one, when I multiply by 2.54, that's going to give me 20.32. And the last one, when I multiply 3.5 times 2.54, that's going to give me 8.89. Now, if we look at the constants of proportionality, we will find that they are all the same, and they are all going to be 2.54. So this is a proportional relationship because all the constants of proportionality are equal to the same number, which is 2.54. So it has a consistent constant, so therefore it is a proportional relationship. For these next examples, we're going to just complete the table using the equation. So we're given the x and we want to find the y. So the first one, we're going to take 4 plus the x. So we're going to add 4 and we'd get 6. And then we're going to add 4 and we're going to get 7. We're going to add 4 and then we're going to get 8. Add 4 and we get 9. Okay, then we want to find the y divided by x. And y divided by x, 6 divided by 2 is 3. 7 divided by 3 is 2.3 repeating. And 8 divided by 4 is 2. 9 divided by 5 is 1.8. So these are not the same. And the next one, we are taking 4 times x. So 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. 5 times 4 is 20. Okay, and then if we divide 8 by 2, we get 4. 12 by 3, we get 4. 16 by 4, we get 4. 20 by 5, we get 4. So the y divided by x on all those is 4. And the next example, we have 4 divided by x. 4 divided by x. So we're taking 4 and dividing by 2 to get our y of 2. And then we're taking 4 divided by 3, and you get 4/3. And then you take 4 divided by 4, and you get 1. And then 4 divided by 5, and you get 4/5. And then we're going to find our y over x. So 2 over 2 is 1. 4/3 over 3 is going to be 0.4 repeating. 1 over 4 is 0.25. 4/5 over 5 is 0.16. So those are your y divided by x's. And this next one, we have y equals x over 4. So you're dividing 2 by 4, and you'd get 0.5 or 1/2. Divide by 4, and you'd get 0.75 or 3/4. And 4 divided by 4 is 1. 5 divided by 4 is 1.25. And then we're going to find our y over x. So 0.5 over 2 is 0.25. 0.75 over 3 is 0.25. 1 over 4 is 0.25. 1.25 over 5 is 0.25. So those are all 0.25. And the next one, we're making the x an exponent. So we're going to have 4 to the exponent of 2, 4 squared, which is 16. Then we have 4 to the 3rd power, which would give me 64. And then 4 to the 4th power would give me 256. And 4 to the 5th power would give me 1024. And then we do y divided by x with these numbers. And we would get 16 divided by 2 is 8. 64 divided by 3 is 21.3 repeating. 256 divided by 4 is 64. 1024 divided by 5 is 204.8. And the last one, we have x to the 4th power. So we're going to do 2 to the 4th power, which gives me 16. 3 to the 4th power gives me 81. 4 to the 4th power gives me 256, and 5 to the 4th power would give me 625. And then we need to do y divided by x in this situation. So we have 16 divided by 2, which would give me 8. 81 divided by 3 is 27. 256 divided by 4 is 64. 625 divided by 5 is 125. Now, wrapping all this up, let's see which of the equations that we just created tables for make proportional relationships. So our 6 equations were y equals 4 plus x, y equals 4x, y equals 4 divided by x, y equals x divided by 4, and y equals 4 to the exponent of x, and finally y equals x to the exponent of 4. So of all of these, there were only 2 that had a consistent k value. So we had a k equals 4 on the one where it was y equals 4x, and we had a k equals 0.25 where it was x divided by 4. The rest of them all had different k values for each row, so they cannot be proportional relationships. But these two could be because they had a constant of proportionality. So that would be your reasoning. We'd have y equals 4x because you're multiplying by 4 each time, and y equals x divided by 4 because you're dividing by 4 each time or multiplying by 0.25. What do the equations of proportional relationships have in common? And that's it for your notes on comparing relationships with equations. Make sure you bring your questions to class, and we'll do more practice when you get here.